Hello guys, we're gonna do word search problem. It's a very famous problem and very interesting as well for me. So what we're gonna do is we have to find a word in this board, and the word is adjacent vertically and horizontally. Okay, so let's start. So first of all, we could do some validation. I don't know if that's needed, but it's not needed. It's cool because it says the word can always, you know, they'll always have some data in it, and lowercase, uppercase English letters. Okay, so validation probably not needed, and then yes, we probably need a helper method to basically look for other options, right? I mean, you choose one item and then look for four directions, upper, lower, left, right, up, down. So we need that. So yes, so basically we have some plan. Basically we're gonna start two for loops, basically to go over all the elements, and when and for each element we'll check if that'll start a word. Okay. So int I, and so that let's have the I and j, the traditional variable, I less than board.length, and I plus plus. Okay. Let's type it out. Int j equal to 0, j less than board of 0 length, and j plus plus. So now we're gonna check if the word at position 0 is going to match. Okay, and at any point, if we find the answer, we're gonna return. So if, so we're gonna look for result. So boolean result. We're gonna call a method exist. Let's overload this method. So we're gonna pass the word as it is, the word as it is in the first index in the word. Okay, and what else do we need? Okay, let's give it a try over here. So boolean exist. Let's copy this guy. Okay, and I also need the int I and j, right? I and j, the positions, right? The position. I int j, correct? I need the position. So okay, and if result true, otherwise it false. Okay. All right. So here we first want to check if our ing are valid. Okay. So if my I is less than 0 or I is greater than board dot length th ing th less than or greater than equal to, or j less than 0 or j greater than oops j less than 0 j greater than board of 0 dot length, or board of I and j do not match word cat at did I get the word position? Come on, position. Do not match, return false. All right. So as soon as that's the case, you can return. And if that is okay, we can say, so once you know that this is a valid position, that valid word position that matches what's in the board, we have to mark it so that it's not considered again. Okay. So board, if I j, we have to mark it with something like hash. Okay. So that nobody considers this again. When I want to add that condition over here, oops, board I j equal to hash, right? In that case, we don't want to consider that. Okay. And eventually we want to reset this back to the word get plus. Okay. But what you have to do meanwhile is send some result here, and this result is a boolean, right? Because that's our return type. Now here's the situation. You know that your first character matched, that's why you're here. That's the other. If so, here is our gate. I mean, if you don't match at least the first character of that word, or then you're not gonna go here. Now that you're here, that means we need to match adjacent character. Now, what is the definition of the adjacent character? Up, down, left, right. So we have to call this exist function 4 times. Okay. Oops. So exist board word position plus 1. That makes sense. Correct. I j. Okay, so now, so first you want to go left and right. Okay, so if you say left and right, that means j plus 1 and j minus 1. Okay, now up and down. So up is minus 1, down means j I plus 1. Does that make sense, guys? What we have done is we're talking with all our neighbors. We're saying, hello neighbor, do you have at this location in the board, at this new location in the board, does this character matches? If yes, I'm gonna be happy. And since it's an or, we're not gonna execute everything. Like if one of these returns true, we're just gonna return. Just gonna the whole expression will be true, and then in the worst case, all four will execute from each position, right? So that's the worst case. Or 3 does 12, because I was thinking about time complexity, sorry. So basically we're saying we're looking at each position, so that's n squared, m into n, whatever. And then at each position we're taking 3 different options, right? And since we're not taking into account the visited ones, that's why it's 3 raised to 3. I mean, we're doing the, yeah, so 3 raised to word size. Okay, so this seems like it'll work, so let's give it a try. Index out of bound. So we got our word character at position. Oops, we didn't send our position. So board word, and the position is always 0. Oh yeah, we have to also consider, sorry guys, if word dot length okay, is equal to position. That means return true because we found it. All right, so that was the solution.